Okay, so last lesson we looked at using matrices to represent transformations. I showed you there's some really fundamental ones. The matrices that involve just zeros, ones and minus ones are things like reflection in the x-axis, or rotation 90 degrees anti-clockwise, about 0, 0. These are probably the most important ones. But there was an exercise 7C, where I just picked out a couple at the end as we were running out of time, and we had a bit of a chat about them, but we didn't really do any. So I think probably a good idea to spend at least a little bit of period 1 doing some questions from 7C. And I'd like to give you just a sort of a harder example, which is in the spirit of some of the questions you see in 7C. So let's have a go. I've got here a trapezium that's represented by 4 coordinates. I don't know the value of k, but I do know that it's positive and it's less than 9. That's relevant in a moment when I come to sort of sketch the picture out. I'm going to transform the trapezium to get a different shape. It's presumably no longer a trapezium because now the question refers to a quadrilateral, so I guess it I don't know, does some kind of shearing or twisting or something like that, so that it's no longer a trapezium. But I do know the area of the new one, the area of the transformed one. This should be enough information to work out k, and therefore I know all the coordinates of the original trapezium. Right, let's go ahead then and try solving this. So there's one coordinate I can plot straight away, and that's the coordinate 9, 1. So if I label that 9 and that 1, then I can put 9, 1 there. The others I don't know, so I'm going to pick a place for k. I think I'm going to put k there. I know it's somewhere between 0 and 9. I don't know where exactly. Let's stick it there. It's as good as any. So k1 is going to be there. I've got k4, and on this scale I've got 1, 2, 3, 4. Although scale's a bit fruitless because I don't know what k is, but never mind. So I'll put 4 there. K4 is therefore going there. I've done the 9, 1. I've got 9 and 4k. Well, on my scale, if I've said that sort of 2.5 squares is worth k, then 4 squares is 10, isn't it? So that puts it up here, where that is 4. K. I've still got no idea what k is, but you know, it's something like that. And here's my trapezium then. Looks something like this. And I know some of the lengths on this. So this length here stretches from 1 up to 4. That must be a length of 3. I don't know the length here, but I can write an expression for it. This length along here is 9 minus k. In the same kind of way, I don't know this length along here, but I can write an expression for it because it goes from 1 up to 4k, so it's just the difference. That length there is the difference between 4k and 1. So I've got all of the lengths on the original trapezium, but possibly given as expressions in terms of k, not necessarily numbers. I could work out the area of this if I really wanted to, or at least an expression for it. That's going to be well, half the sum of the parallel sides times the distance between them. So half the sum of the parallel sides, these are my parallel sides, 4k minus 1, times the distance between them, which is 9 minus k. That in my head simplifying gives me 4k plus 2, and half of 4k plus 2 is 2k plus 1. And that will be the area of this shape here. The question does actually tell me the area, not for this shape, but it gives me the area of the new shape after I've done this matrix to it. If I work out the determinant of this matrix, I would know the area scale factor of any sort of enlargement that's going on here. Determinant of this, we have 3 times 0, which is 0, take away minus 2 times 1, so we've got 0 take away minus 2, it's 2. So my area scale factor is 2. So this might do all sorts of things. This could do rotating, this could do reflecting. There's another one that I haven't shown you because it's not in the A-level course, called shearing, and that's where you sort of like move the shape. I don't know how to describe it. Look it up. It's called shearing anyway. It's quite a nice transformation, but it's not one that we do at A-level. It could do any of those things, but some part of this is obviously doing an enlargement or possibly a couple of stretches, because the area of the new shape is twice as big as the area of the original shape. If the new shape has 84, well, the original one must have had 42. Okay, because this one is twice as big. So the original shape, the one I've got in front of me here, this trapezium, must be 42. It's always difficult to know how much detail to give, so forgive me if I'm repeating myself and going around in circles. So just to recap, I've got a trapezium that was described. I didn't know all of the coordinates exactly. I had some K's in there. I drew a sketch of it. I didn't necessarily need to draw a sketch of it, but I think it helped me understand what was going on. Some of the lengths of the trapezium I definitely knew as numbers, like this length here I know is 3, one of the parallel sides. The others I've been able to write expressions for. This is an expression for the area here, which simplifies to this, 2k plus 1 times by 9 minus k. It's an expression for the area of this. But I know that if I use this to transform this, I get a new shape, possibly not a trapezium anymore, and the new shape has that area. Since this has determinant 2, that's the area scale factor of any enlarging part. So if the new shape has area 84, the original shape was half the size, because this is twice the size of this. Therefore, 42 is the area of this thing here. This is just a quadratic equation, so I will attempt to solve this quadratic equation now. Feel free to skip this part, I am just solving a quadratic, so I'll expand this out. That's 18k minus 2k squared, add 9 minus k. Let's put the 2k squared on the other side to make it positive. This is 17k, which if I take on the other side is minus 17k. I've got a 42 over on the left already, and if I take 9 off, 42 take 9 is 33. This thing I reckon probably factorises. So let's do a pair of things at times to give positive 33, probably 11 and 3. Can't put the 11 there because that would make... Actually, I can put the 11 there. That's where I should put it, because that's 22, that's too many. Let's put the 11 there and the 3 here. Factorising in my head, always good. They're both negative. Let's just check that works. So 2k squared, take 6k, take 11k. Yep, that's the minus 17k I need, and that's plus 33 now, as it should be. Therefore, I get that k is 3, or it's 11 over 2, also known as 5.5. And they are my two possible values of k. If I just have a look at what that does up here, in the k equals 3 case, that would mean I've got a trapezium where that's 3 and that's 12 up there. And you can check if you like, because if this number here is 3 and this is 12 up here, then I've got 6 along here. The sum of the parallel sides will be, that's going to be 11, so sum of the parallel sides is 14, half of 14 is 7, and 7 times the 6 is indeed 42. So that number definitely works. If I take the 5.5 solution, then we're making this narrower here, but this longer up here, because 4 lots of 5.5 goes all the way up to 22. So that's much longer, but much narrower as well. And it also works, feel free to check it